Hi, I'm Phil, and in this video, I'm going to explore the Kitronik LED tile for microbit. And I'll be using a mind map to describe it and look at the hardware, how you can develop the software, and a couple of projects I've worked on, and finally a critique and a review. So this particular tile is an 8x8 panel for microbit. So it's actually a Neopixel array, and you get quite bright colors from it. The colors are quite broad, and it's quite easy to use. So it arrived about 3 days ago, and I've already constructed 3 projects with it. So the hardware is described here, and it bolts on to the microbit computer. There's plenty of help available if you want to develop your own software. And Kitronik have a microcode extension. So if you use these blocks, it's quite easy to develop your own software code. The 3 projects I worked on, the first one was a clock. The next one was constructing numbers for my house. So I've got a house number display. And the final one is a timer for autistic people, and plenty of future projects that I'm interested in using this piece of hardware. So the clock project, it uses a software real-time clock, and it then uses both the colors and the large font sizes that are displayed. So what I'm doing here is the hours are shown in red and the minutes are shown in a blue font. So for the hardware, I'm using a microbit together with the Kitronik zip tile, and I just bolt these together. The software code for this is illustrated here. So the tiles or the blocks are all you have to do is just fill those in. And what I'm doing here is to set my real-time clock to 1:30. And if I press button A, I just do a demonstration of displaying a rainbow. And button B shows the color red. But at other times, I'm showing on the microbit LED array the fact that hours are going to be displayed, and those hours are displayed in red on the Kitronik tile. Then I just repeat this 4 minutes using the blue color. There's not much here in the code. And there's a startup, followed by the forever and the events loop. So if I press button A, B, or if I want to scroll some text, here I'm only scrolling the number 7. It's not like the scrolling on the microbit computer. It scrolls right across and you lose even your single character. So you have to think of ways, if you want a permanent number or character displayed, you've got to think of other ways of doing that. And that's what I wanted to do on the next project, which was the house project. So I needed an algorithm just to construct the number 7. I didn't want it to scroll. I wanted it to be permanently displayed. And this is my house number displayed on the LEDs. The final project is a timer for autistic people. And it's based on the Time Timer, which is a commercial product. And it allows you to set a time. So if you look at the photo on the right, there's the time timer, and you just dial up the time that you want, and the alarm goes off and it shows you how much time you've got remaining. Well, I'm duplicating these functions, but instead of using red, I'm going to use green LEDs to indicate that you can go, and it tells you how much time is remaining. And here's the code for doing that. So there's a fair bit of additional code that's been added here for debugging, and I could reduce some of the size of that code.
This is TAP, a timer for autistic people, and it's based on the timer or time timer. So you set a time with timer and it counts it down. And I first developed this a number of years ago with Arduino computers and Neopixel arrays, and it was promoted by Seed Studio a number of years ago. In this version, you select with the button B of the microbit the time that you want. So there's 10, 20, and I'm using a increment here for demonstration only of seconds rather than minutes. So to start the timer, you press button A on the microbit and it counts down. The green lights show you how much time you have remaining, and it will count all the way down to 0. So time's up, and it will give you a warning. So it's now finished, and if you wanted to start it again, you just simply select the time interval, 10, 20, and you can then start the timer. So S is shown on the microbit for start, and it's counting down. The display is a tile LED matrix from Kitronik, and it bolts on to the microbit computer on the top. So you can get any color you want, and it's a 8 by 8 array. This is the Kitronik Neopixel Tile Array. So it's an array of color LEDs in an 8 by 8 matrix. Here I've got it programmed to be a clock. So it's using a software real-time clock. It's showing the hours in red and the minutes in blue. So the hours are coming up now. It's after 2 o'clock, and the minute is 5 minutes past 2. So it's an attachment to the BBC microbit, which sits on top, and it's powered by its own battery box. So here there's two 3.3 volt batteries, and that's the Kitronik tile, and it's a LED matrix. And perhaps just to give you a bit of a demonstration, on this one, when I press button A, you'll get a very colourful display. So, and it shows you some of the colours. So you can get very bright colours using this device.